It is given that assuming the sun to have a spherical outer surface of radius r, radiating like a black body of temperature T degrees Celsius. So over here we are considering that sun is like a black body. So the value of E we can take it as nothing but 1, and radius of sun, it is given as nothing but small letter r. Radiate like a black body at a temperature of T degrees Celsius. So temperature is given as T degree Celsius. The power radiated by a unit surface normal to the incident ray at a distance r from the center of sun is. So Rm is to find out on a surface which is at a distance r from the center of sun, where the Rm is to find out the value of energy radiated per unit area over there. So we can first find out what about the value of energy which is emitted by the sun. So the power radiated by the sun will be equal to, we can use this equation, E sigma A, temperature of object raised to 4. So according to this question, the value of E is given as nothing but 1 sigma into surface area of sun, we can take it as 4 pi into small letter r square into temperature of sun, which is given in T degrees Celsius. We need to convert it into Kelvin scale, so we can add 273. So T plus 273 raised to 4. Now Rm is to find out the value of power received by a unit surface, means a unit surface of unit area. So we can write the value of power per area. So we can say that the total energy is going to spread in a sphere of radius, let's say capital letter R. So we can write this is equal to sigma into 4 pi r square into T plus 273 raised to 4 divided by area of a surface in which it is going to spread is 4 pi capital letter r square. So we can write this 4 pi and 4 pi, we can cancel this. So this is sigma into r square into T plus 273 raised to 4 divided by r square.